This is Physics 2212, Lab 3 circuits. The purpose of this lab is to predict the behavior of circuits containing resistors in series and parallel. The main principles used were energy conservation and current conservation. The system was found to be the circuit, and the surrounding was found to be everything else. And the result was found to be that in the DC circuit, the electric current was equal to 0.019 amps, and the change in potential in the whole circuit was equal to 0. In the RC circuit, the capacitor with the 5 ohm bulb was equal to 11.4 seconds, and the capacitor with the 3.8 ohm bulb discharging was equal to 12.9 seconds. The main principles formulas were energy conservation, where it states that the sum of potential in a loop is equal to 0. In current conservation, the electrical current in is equal to electric current out. And then Ohm's law states that the change in potential is equal to the electrical current times the resistance. So the DC circuit, we connected a 47 ohm resistor in series with a 100 ohm resistor connected to two batteries. So at I1, we found that it was equal to 0.0189 amps, and I2 was equal to 0.0191 amps. And this makes sense due to the current conservation law. When I1 ammeter was changed to a voltmeter, the voltmeter was read to be 2.9 volts, and the I2 ammeter was read to be 0 amps. The 47 ohm resistor was found to be negative 0.9 volts. Through the 100 ohm resistor was found to be negative 1.9 volts. And through the ammeter was found to be 0. And then through the battery was found to be 2.9 volts. When summing all this up together, it was equal to 0.1 volts, which is about equal to 0, which corresponds to what the loop rule states. This is a graph of the potential to position around the circuit. As you can see, when it goes through the batteries, it increases up to 3 volts. But when it goes through the resistors, it goes down, all the way down, summing equal to 0 volts, which is also corresponding to the loop rule. So the DC circuit questions asks that when you attach the voltmeter, you alter the circuit. Why doesn't the ammeter reading change? This is because the voltmeter has a high resistance, so the circuit goes through path with the least resistance, which is the 100 ohm resistor. Now, when you replace the voltmeter with an ammeter in parallel with the 100 ohm resistor, what happens to the current through the other ammeter and why? Well, the other ammeter increases from 0.00199 amps to 0.00514 amps. And this is because the ammeter provides an alternate path. So the resistance, when calculating the resistance of the circuit elements, the 47 ohm resistor was found to be equal to 47 ohms. And the 100 ohm resistor was found to be 100.53 ohms. If we take into consideration that there was a remaining 0.1 volts, when summing up the potential, the wires will be equal to 5.24 ohms, and the ammeters would be equal to 0 ohms. These are pictures of our DC circuit while in the lab. And in the RC circuit, we first measured the resistance in the gold bulb and silver bulb. The gold bulb was found to be 5 ohms. The silver bulb resistance was found to be 3.8 ohms. When connecting the capacitor and battery, the brightness of the bulb didn't change over time. But when the bulb is only connected to a charged capacitor, the brightness of the bulb decreases over time. And when charging the capacitors, it is instant. But when discharging with the gold bulb, it was equal to 11.4 seconds. When with the silver bulb, it was equal to 12.9 seconds. And notice how this doesn't make sense because it's supposed to be that the higher resistance, the longer it takes to discharge. But this is likely due to an error on our part when doing the lab. And this is a picture of our RC circuit. Now, what if we charge capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Ideally, the charge would be instant. But in practice, there is resistance, like in the wire, so it would take some time to charge the capacitor. And to conclude, we found the behavior in the DC circuit and RC circuit by using Ohm's law and energy conservation and current conservation.